Hello and welcome to my YouTube channel. Today we shall be looking at the integral of 1 over a squared plus x squared with respect to x. We should recall that if y is equal to the tan inverse of u, then if we differentiate dy over du, we get 1 over 1 plus u squared. Since integration is the reverse of differentiation, it will follow therefore that if we integrate this function, so the integral of 1 over 1 plus u squared du must give us what? The tan inverse of u plus c. So this is what we know. We're going to use what we know here to integrate the function that is required. So to integrate this function, we are going to make it look like what we already know. We're going to make this function look like the integral of 1 over 1 plus u squared. There is 1 here, here there is a squared. There is u here, here there is x. So let us start by making a squared to be what? 1. So if we factorize a squared in the denominator, what do we get? We get the integral of 1 over, we take a squared out, what is left here is 1, plus x squared over a squared. So a squared times 1 is a squared, okay? A squared times x squared over a squared is x squared, since a squared will knock off the a squared down, correct, with respect to x. We can simplify again. So this is a squared, is a constant. Since we are doing with respect to x, we can take 1 over a squared out. We have the integral of dx over, what is left here is 1 plus, I can write x squared over a squared as x over a all squared. If we compare this integral here with what you already know, what's the difference? Here is u and here is x over a. So if we now say that let u be x over a, what happens? We now know that du over dx is 1 over a. If we now make the x the subject of the equation, we get cross multiply, we have a du is equal to what? Dx. So back to our integral, where we have dx, we shall replace with a du, and where we have x over a, we shall replace with what? U. So the integral here becomes 1 over a squared integral dx is now a du over 1 plus x over a is now what? U all squared. There are two a's down here, there is one up, so one of these will cancel one down here, and what we have left is 1 over a integral of 1 over 1 plus u squared with respect to u. If we compare what we have now with what we know already, what do we observe? The integral of 1 over 1 plus u squared du is what? Tan inverse of u plus c. And that's what we have here now. So we have here the integral of 1 over 1 plus u squared must be what? Tan inverse of u. So this gives us, we have 1 over a out here, 1 over a tan inverse of what? Of u, plus our constant c of integration. This is equal to 1 over a tan inverse of u. What is our u? Our u is x over a. Tan inverse of x over a plus c, our constant of integration. Therefore, the integral of 1 over a squared plus x squared with respect to x is what? 1 over a tan inverse of x over a plus c. Let us now take one or two examples to illustrate how to apply this formula directly. Example 1. We have to evaluate dx over 9 plus x squared. So we look at what we know already. We have already discovered, or rather evaluated the fact that the integral of what? 1 over a squared plus x squared dx is what? 1 over a tan inverse of x over a plus c. So we must know what our a is here. Before we do that, we rearrange the equation and we'll have the integral of dx over, we can write 9 as 3 squared plus x squared. So that our a is what? 3. A squared, 3 squared, so a is 3. So the integral of dx over 3 squared plus x squared will now be what? 1 over a. Our a is 3, so that is 1 over 3 tan inverse of x over a. Our a is 3, x over 3 plus c. The constant of what? Integration. And that is it. Example 2. We want to evaluate the integral dx over x squared plus what? 16. So again, we compare with what we have here. So we have here x squared is x squared, and then a squared is 16. So we can rewrite this as the integral of dx over 16 plus x squared, so that x squared will come last, if you like. We can still write this again as the integral of dx over 4 squared plus x squared, so that our a is what? Our a is what? 4. Since we know that the integral of a squared plus x squared is what? 1 over a tan inverse of x over a plus c. So this integral given to us will be what? Will be 1 over a. What's our a? Our a is 4. 1 over 4 tan inverse of x over a, x over 4 plus c, our constant of integration. Exercise. Evaluate integral of dx over x squared plus 4 using the technique we have just learned. Leave your answers in the comment section below and subscribe to this YouTube channel. Thank you. Bye-bye.